Go. We're good?
Good.
Do we remember any of these?
Okay. Fast test, right?
Okay. So before I go into that, let me just quickly finish renewable energy. And maybe I'll ask Ricky to help me out here a little. So when it comes to renewable energy, I think the first, going back to our 2030 story, ask appropriate questions, find the facts, provide the reasons for using the facts, and then finally use analysis tools to validate your decisions. Okay, so even though it sounds simple, it's very important to ask these questions. What is your building's EUI? What is your building design's EUI? The design that you're dealing with. Energy use intensity. And what is your target? The 60% reduction target, 70%, what is that target? And then how much do you want to offset by any of the renewables? It could be PV solar panels, or solar hot water, or wind, or any other type of renewables. So it is important to ask these three questions in your project. Once you have, so let's just run through an example. For a typical school in Phoenix, let's say the EUI for an average building out there is about 60 to 70 kBTUs. So your target EUI would be, for 60% reduction, would be somewhere in the range of 24 kilobTUs per square feet. Let's say your building design, as of during the design process, is at 34 kBTUs per square feet. So you haven't met the target yet. Okay. So at this point, you've done everything you can with, remember our pyramid, you've stretched the comfort, you've designed your building envelope, you've made the lighting PSALI technique and made it very, very efficient, and then you've provided enough HVAC that's very efficient. So we've done all these different steps, and you could only get to 34. Now to meet this 24, you need about 10 kBTUs per square feet. So that's where the next question is, how much do you want to offset? Ignore this for a second. How much do you want to offset off this 34? That's the big question. If the answer is, I want to offset 100%, then you want to be able to produce 34 kilobTUs per square feet per year, correct? Which would translate into 10 kilowatt hours per square feet from BTUs to just a conversion factor. So, but if you say, I don't have enough money, I'm only going to go for 50% offset, then 5 kWh per square feet per year. So it's very important to know what you're shooting for. Okay? Then you can design the system. Okay? So, when it comes to PV design, I'm going to just go through the steps, and maybe I'll ask Ricky to come and go through an example here. These are some 6 steps that's involved in PV design. And you can take these 6 steps and apply it to any other renewable energy design also. So the first step is to find out what is your EUI. Let us say our target from that previous slide is 10 kWh per square feet, if that's what we want to offset, okay? So that's our offset EUI. Then you want to know your project square feet. What is your building? Is it a 20,000 building, whatever, right? And then you want to know what the production factor of PV, and Ricky will explain what that is. It's basically, well, I'll let you go deep into that. Okay. Then we'll find out what the system size using these 3 numbers. Then based on the system size, we will figure out, we will use a particular panel. This could be, a very expensive 230 watt or 300 watt per panel solar panel, or it could be a very cheap panel, whichever you could afford, because that's going to determine how big of a roof that you need. So then you figure out number of panels that you want, and based on each panel square footage, you can figure out how big of a PV panel that you have, that you need. You want to walk up and go through a step?
So now we all know what our EUI is, hopefully. You use that number to determine basically the kilowatt hours you're going to want to offset for the year. So this is the equation you go through to figure out your system size. So you know your kWh per square footage per year you want to offset. You know your square footage, so you know you have a 20,000 square foot roof you can use. The production factor is an evaluation of, say you have a 17 square foot panel and it produces 235 watts. It's basically the math of how many kWh that panel is going to produce for the system.
Right.
So
let me just add one more item to that. And that production factor 1650 is an average that we can use on our projects, but it depends really on our local design because that takes into account how much shading that happens, how big of a parapet we have, and do we have adjacent buildings, and how many days we have cloudy weather.
So the production factor is more related to the client, and your panel efficiency is more related to the design of the panel itself by the manufacturer.
Right. The production factor is more of a site-dependent number. So it could range from 1,500 to 1,800, whatever it is.
Yeah.
But we choose.
So Phoenix has a different digit than Seattle.
yeah,
But
so
even within Phoenix,
Okay.
your building can have a different production factor because it could be on the south side of a huge parapet wall.
Okay.
So a lot of the information we've been getting for production factor, Sean Avery from Seattle's been way ahead of the game on this solar renewable energy stuff than anybody else in our group. He could tell you pretty much factors for every state for renewable energy. He's gotten grant money to go out and do these studies. So Arizona is like anywhere between 15 to 18 is what we've been finding. In Seattle, he's done some projects that have been going anywhere from 9,000 up to 1,400. So I mean, it just just depends on the area. It really does. The production factor can also take into effect the number of sunny days. And there's assist calculators all over the place that you can get to. Every manufacturer seems to have their own calculator that can help get this information. So there's tools out there to help. So you take that production factor. So to get your actual kW size for a system, because you need to take this to kilowatts and you need to take it to watts to figure out your system, you take your square footage and you times it by your 10 kWh per year, and then you divide it by your production factor, and that gives you your actual system size that you're trying to design to. So what you take then is whatever panel you decide to use, wind turbines, anything, their cut sheet is going to tell you the watts of production for that particular item.
Right.
So you then take that and you divide it into your kW, and what you have to do here, since you needed to get the watts, you times it by 1,000 to get it to your watts. And then that gives you the estimated number of panels you need. There's a lot more to come into now, but this is just the basic. Then you take your number of panels times 20. What are we doing?
That 20 would be the square footage of one panel.
So yeah, that's just a rough square footage of a panel, and that give you your rough size of roof area or parking
So you
structure,
only need
canopy.
So,
Right.
and I think the importance here is, thanks Ricky, the importance in this slide is, this is something everybody could do during the early analysis, right? If we know these two numbers. It's great to have a solar team and we can use them as a resource, but what if you can't avail them when you really have to, right? So just knowing this will get you in the ballpark of how big of a solar array you need, because we've chosen all the medium range items here.
Okay.
So from there, it either grows or reduces, but it's a good metric to start with. Okay?
How much was that offsetting?
10%.
Well, that's irrelevant. I guess what I'm getting at is if you say this is 100% of your offsetting, then that's 10
Yeah, that
kilowatt
would
hours.
be-
Whatever that number is.
Was that 100%?
That was
This is just
134.
Right. This is just an example. Well, you can't really say for a 20,000 square feet office, I need 10,000 square feet. This is just an example. So it really depends on what that number is.
Yeah. Okay.
Okay? Good, everyone?
Good.